Okay, so this video is basically walking you through the key for calculating formula molecular mass, the worksheet that we did in class. And so I'm going to provide this as a tool that you can have as a resource to study for any questions that you missed. And so let's say that you missed number 9, well, you can scroll through the video until we get to number 9. But I am going to go in order 1 through, let's see how many are on here, I think 15. Nope, 25. That's a lot more. But you'll see that the process is pretty much consistent. So scroll to the video wherever you need the most help. Okay, so directions say write the chemical formula for each of these compounds and then find the formula mass for those which are ionic and find the molecular mass for those which are molecular. You must show all work. Key thing to receive credit. Be sure to include proper units. Okay. So the first task in any of these problems is to obviously write a correct formula. Now, the formula portion we learned last unit, in Unit 4. If it's an ionic substance, you'll need to remember the ions that we covered. If it's a molecular substance, then most likely you can look at the prefixes and write the correct formula. So in number 1, dichlorine heptoxide, chlorine, you're going to have 2 substances of chlorine. Hept is 7, so O7. So once you write the correct formula, then we're going to list the atoms underneath each other. We're now going to take 2 chlorine atoms. We're going to put the mass from the periodic table, 35.45. Be sure to round it to 2 decimal places. 7 times the mass of oxygen, which is rounded to 16. And then once you have this portion, you can just type that directly into the calculator. If you're using your TI or TI-83 or Inspire, I would type it in directly what you see using parentheses and all, and you will get a mass of 182.90. Do keep 2 decimal places, and the unit on the entire worksheet will be gram per mole. Okay, number 2, cesium sulfite. And what I may do is just show you a few of these and then walk through and show you all of the proper formulas. Cesium sulfite. Cesium is a metal, so we automatically know we're having the ionic substance. Cesium is in group 1, it forms a 1+. Sulfite is a polyatomic ion that you need to have memorized. SO3, 2-. The charges are not balanced, so you do need to crisscross. Our correct formula is CS2, SO3. Okay, once we write the correct formula, we list the elements, 1 sulfur, 3 oxygen. We go to the periodic table and find the correct molar masses. Be sure to keep 2 decimal places on all the molar masses pulled from the periodic table, and also round properly if needed. You can type this directly into the calculator all at once. 2 times 132.90, close parentheses, plus 32.07 plus 3 times 16 in parentheses for a molar mass of 345.87 grams per mole. Now I am kind of doing this fast. If you do catch a mistake on your end, please compare it to mine. Be happy to give me feedback. Okay, number 3, Stanek Hydroxide. Stanek is one of the other metals, so we know it's an ionic compound, but this is a type 2 metal that can have more than 1 ion charge. Stanek, the ic version, represents the higher charge, so SN4+, hydroxide is OH minus. This is one that a lot of people miss on the final exam. OH is a polyatomic ion, so when we crisscross this, the OH must be in parentheses. Okay, so we have 1 SN, we have 4 oxygens. Remember, the parentheses includes the entire polyatomic, which there are 4 oxygens and 4 hydrogens. Okay, going to the periodic table now, 1 tin atom is going to be 118.71, 4 oxygens at 16 each, 4 hydrogens at 1.01 each. I can add all of those up in one swoop. for a molar mass of 186.75. And I do want you to put units on these because I want you to get in the habit to know that molar mass is grams per mole. We're going to be using these later on as conversion factors. I'm going to do number 4, and then what I'll do for the rest of these is just go through and write the formulas. The process of adding up the masses is going to be the same, and then you can compare your key to the key that's provided on your paper. So Plumbec is lead in the highest state, so just like tin, we know it's a 4+. Oxalate, if you remember back from the story, the dream that I had, it's C2O4, 2-. It was that ox with those C-shaped horns. He had 2 heads, 4 legs. Now this one is a hydrate, and so once we form the initial ionic portion of it, which a 4+ and a 2-, we want to balance that charge out. C2O4 is in parentheses, but I just have a 2 on the outside, not a 4 and a 2. My dihydrate is 2, so 2 H2Os. Now it's a pretty long formula. Okay, now when you count these, you do need to count every element, and so I like to just list my elements left to right. Let's see if we can zoom in a little more. I've got 1 lead. I am going to write a little bit smaller. I've got 2 times 2 carbons, which is 4 carbons. 2 times 4 oxygens here, which is 8. The water, the 2 in front, will be multiplied to everything behind it. So 2 waters represents 2 times 2 hydrogens, which is 4. 2 times 1 oxygen, which is 2. Now, some people like to go ahead and combine total number of oxygens. You can do that if you want. I just do them separate, read them left to right. It's the easiest thing for me. So 1 lead is 207.20. 4 carbons at 12.01 each. 8 oxygens at 16 each. 4 hydrogens at 1.01 each. And then 2 oxygens at 16 each. And so I'm going to add all of these up. I'm just going to type them all into my calculator. 207.20 plus 4 times 12.01 plus 8 times 16 plus 4 times 1.01 plus 2 times 16. Enter, we get a molar mass of, or I'm sorry, a formula mass of 419.28 grams per mole. You can pause and rewind at any point. Now what I'm going to do is just go through the rest of these and make sure that you have the right formula, and maybe that'll be kind of a refresher from Unit 4. But as far as the work is the same for adding up the masses. Count the number of atoms you have, and then you get the masses from the periodic table, add them up. Okay, so magnesium is a metal. Magnesium is in group 2. It's a 2+. Nitrite is a polyatomic that we've memorized. NO2, 1-. Not an even charge, so we do need to crisscross. Nitrite must be in parentheses, so MgNO2, 2. Potassium phosphide. Potassium is a metal. K+. Phosphide, the IDE ending. We can look straight at the periodic table and know that it has a 3- charge. So my formula is K3P. Number 7, mercuric chloride. Mercuric is mercury in the highest state, mercury 2. So Hg2+. Chloride, we can look straight from the periodic table. And then when we crisscross those, we get HgCl2. Barium, it's a metal. It's a group 2 metal, so it forms a 2+. Bicarbonate is a polyatomic ion that you should have memorized. HCO3, 1-. When I crisscross those, Ba, my HCO3 is in parentheses, and so on. Okay, hopefully that will stay on this page. Ammonium is a polyatomic, NH4+. Chromate is another polyatomic, so CrO4, 2-. When I crisscross those, since it's an uneven charge, only the ammonium ion needs to be in parentheses. Oxygen gas. Okay, so you got to think about your diatomic elements. Oxygen is one of those from the Brinkelhoff group. where oxygen gas is O2. And I'll do this example right here. 2 times 16 is 32 grams per mole. And this is one that you'll want to watch out when we get to mole conversions that a lot of people miss because they forget that it's a diatomic element. Strontium, Sr, 2+, it's in group 2. Cyanide, a polyatomic ion. The Cn must be in parentheses because we need 2 of those groups. Last one on this page, and we can go to the last page. Silver is one that you should have memorized, Ag+1. Perchlorate, remember chlorate is one that we've memorized. Per means 1 more oxygen, so ClO4, 1-. This is a 1-to-1 ratio. My formula is as followed, AgClO4. Okay, going to the last page just so you can have this as a reference. Ferrous, OUS, this means it's the lesser charge. Fe forms a 2 and a 3, so the lesser charge is a 2+. Phosphate, polyatomic, PO4, 3-. So Fe, 3, PO4, the 2 goes on the outside because we do need 2 of those groupings. Ferric, this is the higher charge. Oxide, the IDE ending, means that I get it from the periodic table. I can predict that it has a 2 negative charge. When I cross these, Fe2, O3. Nitric acid, let's talk about rules for acid again. If it's an ic acid, that means it came from the nitrate version. I'm pairing nitrate with H+. So H+ and NO3, balance the charge, just like an ionic compound. Cuprous, OUS, is the lesser charge. Copper forms a 1+, nitrate, NO3, 1-. It's a 1-to-1 ratio. CuNO3. Cadmium is a metal. Okay, this is Cd. It's in it's number 48. It forms a 2+ charge. This is another one that we would have memorized. Okay, dichromate, even though it has prefix, this is actually a polyatomic that we've studied. So dichromate is 2 chromiums. 7, think about the dice, the fuzzy dice from our story. Okay, we had a fuzzy dice made out of chrome. One die had 2 dots on it, the other had 7. Okay, and so since this is a 2+, 2-, these are just going to cancel out. Zinc nitride. Zinc is one that you should have memorized. It's a 2+ charge. Nitride is a 3-. We get that from the periodic table. When you crisscross these, Zn3, N2. Diphosphorus pentoxide. Both these have prefixes. Both of those are covalently bonded together because they're 2 nonmetals. So diphosphorus, P2. Pent is 5, O5. Last stretch, number 20, cupric. Cu2+, it's the higher charge. Bromide, we get from the periodic table. Cu, Br2. Acetic acid comes from the acetate ion, so Chao 232. Balance the charge out. This one actually has 2 formats of the formula. I don't care which one you put. You still get the same number of elements and same number of atoms. You should get the same molar mass. Ferric, higher charge, Fe3+, acetate. I always like the Chao 232. Like I said, you can use the Chiku version if you want. Fe, Chao 232. Needs a 3 on the outside, or the other version is CH3, COO3. Number of atoms still should match. 3 more to go. Stanek phosphite. Stanek is the higher version, so 4+. Phosphite, PO3, 3-. Remember, phosphite and phosphate are the only 3 negative charges that we have. It's not balanced, so we're going to crisscross these. The PO3 gets the parentheses with the 4 outside of it. Chlorine gas. None of those Brinkelhoff elements. Cl2. And the last one, 25, ammonium, which is NH4+, permanganate, which is a polyatomic that we have memorized, MnO4, and this is a 1 minus. Penta, now we'll come to that here in a minute, it's a 1 plus and a 1 minus, those just cancel out. Penta is 5 waters. So hopefully writing those formulas will help. You should have the key to check after doing the first 4. You can look at the key online and see where you made mistakes.